You've completed the first step in adding a RecyclerView, adding the dependency and adding the RecyclerView to the layout. The next step is to craft the items that will be displayed in it, and create an object called a view holder that we'll use to store references to that item. In this app, the list scrolls vertically, so each item corresponds to a row of data. However, as we learned earlier, RecyclerView can display these items in a horizontally scrolling list, which would make the item a column, or in a grid. Because of this, I'll use item when talking about the row layout, because that doesn't suggest a specific layout preference. All right, we begin by opening up Exercise 2, View Holder. You notice the first to-do is to create a layout resource called numberlistitem.xml. So we go to New Layout Resource File, and create numberlistitem.xml. That was fun. And the second to-do here is to make the root element a frame layout. So we'll do that. Android Studio has nicely set the layout width to match parent and the layout height also to match parent. Let's add 16 dps of padding. Create a single text view as the child of the frame layout. Set the height and the width to wrap content. Lastly, set the font family to monospace and the text size to 42 SP. Note, we've used SP and DP when we've referred to dimensions in Android layouts. These are both not actual pixel sizes, but are automatically scaled to be the same approximate physical size regardless of the density of the pixels on the screen. The first Android phones were 160 dpi, and 1 dp would actually equal 1 pixel on these devices. The conversion of dp units to screen pixels is simple. px equals dp times dpi divided by 160. Many modern devices have 480 dpi or more. SP work like DP, but are also scaled based upon user preferences, typically the text size preference. If you want your text to scale up with this preference, which is important for accessibility, make sure to use SP for fonts and widgets that have hard-coded sizes that contain fonts. We're halfway there. We've created the layout for our item. Now let's build the code that will hold references to these views we just created. The rest of the code is inside of the green adapter class. We begin by creating our view holder class in an inner class of green adapter. We call this class numberViewHolder. Since we only had one text view in our layout, we'll create a single text view member variable. We'll then create a constructor for numberViewHolder that accepts a view called itemView as its parameter. Within that constructor, we'll pass the itemView to the superclass and set our text view member using a cast and find view by ID on itemView. One of the most important things a view holder does is cache these references to the views that will be modified in the adapter, since find view by ID can get expensive. We'll then add a convenience method called bind, which helps make our code a bit more readable. It takes an integer and calls setText using, and this is very important, the string representation of our list index. Our code uses value of. The setText function on text views has several different signatures. The first one here takes an integer, but that's not the one we want to use. If we pass in an integer, Android assumes we're giving it a reference to a string resource from strings.xml to display. In the best case, it'll display incorrect text. In the worst case, it will crash our app. We want to print the actual integer itself, so we need to use this signature of the function. There are several ways to do this. We can use value of on the integer wrapper class to get an integer object and call toString on that object. Or we can rely on string concatenation.